So last 20 years data is required in that case. So it also depends on my subject-oriented data. Now suppose it's a company which is into, it will have any kind of data with inside its database. So this company which is into retail marketing or retail business will not have data which is not concerned with it. Okay, so subject-oriented data is something wherein the only aspects for which we are interested about. Okay, if we want to look for all the kind of subjects relevant to that particular company, so we have to go for that kind of data. Okay, we did not have any kind of redundant data on it. Okay, so only those data which are relevant, which are going to be relevant, for which we need to generate reports, only those data are required. So that is what meant by subject-oriented data. First is consolidated and consistent data. I told you that we have data marts. Data marts can have our department-specific data. Yeah, so data mart is something which has only a specific. While making a data warehouse, we will consolidate all our data from various departments into one particular place. All our data from various departments. So that is how a data warehouse is identified. And the fourth thing is it has to be non-volatile. Non-volatile data means the data need not be changed once it has entered the data warehouse. It is usually not recommended, but often people go ahead and create certain jobs wherein recent changes in the database, OLTP database gets reflected in our data warehouse as well. But data warehouse is more or less a non-volatile data where data need not be changed until unless there is a major kind of change which has happened in the parent OLTP database. So what is the metadata? Okay, an OLAP server maintains information about data in the data warehouse. Okay, this kind of information regarding what kind of data is it? Is it integer data? Is it a string data? Okay, what is the structural data warehouse? And what kind of analysis tools of OLAP, data mining, or ETL would be required for it is maintained using metadata. Metadata is necessary for efficient operations of the data warehouse. It is used to acquire and transform and access data. Acquired metadata maps the conversion information from the OLAP, from the OLTP system to the OLAP system. There is actually a conversion which takes place while you move our data from OLTP to our OLAP system. Let me show you how. Now this is something we have in our AdventureWorks, but if I want to look ahead, this particular table, this is my dimension table for employees. Okay, this is my dimension table for geography, and this is my dimension table for organization. Now look, if we have a fact table regarding it, now look at these two tables. This one is a table which is a fact internet sales. Okay, it has got columns like product key, order date key, due date key, ship date key, customer key, promotion key, currency key, sales territory key. All these are keys. All the other columns are the relevant information regarding it, which are called as measures. So what is happening over here is this product key column is into a kind of relationship with this particular product key column of my dim product table. Okay, so if I look into my this fact internet sales, if I look for my 310 product key, if I want to go for this particular 310 product key, I want to look for more information regarding it. So it's telling me all the information regarding it. What is the product name for it in various of the languages? What is the color of the product? What is the safety stock level for this particular product? Okay, so it's telling me only the details regarding this particular product. Similarly, so whatever product your order date key we have, This would also be linked to some other order date. So it could be a date, dim date. This is the column. So this is the table with which this has got a relationship with. All the date columns are getting into a relationship with dim date table itself. Whether that be order date key, due date key, ship date key. These are date columns, and these dates are getting relevant relationship into dim date table itself. Okay, so that we have to keep in mind. Then we have this customer key. Okay, so for customer key, I will have to look for a table which will have my relevant customer data. I cannot find it right now, but it could be somewhere or the other, either in some other tables or something like that. So all these keys, what is happening is, there is, let me show you with an example. So what I'm doing right now, I'm trying to open an existing OLAP database, okay, which has been made. So what we need to do, first of all, is using our SSIS, we have to perform ETL tool, ETL operation, which is extract, transform, and load.
Load, yeah.
Okay, so for now you can see this is something I got regarding this database. So look at this particular diagram. Doesn't it look very confusing one?
It is.
No, it is. It looks like a very confusing one, isn't it? There's so many tables involved.
And from where the flow is going and where it's finishing, I don't is no.
Yeah. So when it's difficult for anyone in the beginning to make out, especially when we are new to this particular database. So that's the reason we have tables. Okay, so you can see there is a table naming convention over here. This one is the internet sales fact table. The same table which we were talking about right now here. This is a 2012 system, and the data warehouse which I have on my system is a 2.8 one. Okay, which I have implemented on my system is a 2.8 one. So here we have internet sales fact over here. Now look at all these tables. Sales reason. This one is another fact table. Internet sales fact reason. Internet sales reason facts. So they are going to be different kind of tables over here. Okay. Now this one is upload data table, reseller data table. Now also look at the name of this particular table. Friendly name is geography, but the actual name is dim geography. Okay, over here, if I look for the customer, my friendly name is customer, but my actual table name is dim customer. So in the very beginning, while we are going to design first of all a simple database, what we are going to have is this kind of data. A star schema, where there is going to be a single fact table, and from that fact table multiple dimension tables would be linked. This is called a star schema. Okay. So I'm not just trying to make it as simple as possible. This one is, while we have a very big project and we have to make a data warehouse, then we have something called this kind of figure. Otherwise, I will have only one single fact table, and there will be many dimension tables which will be attached to it. Okay, and once we have this database, look, this one is the internet sales fact table. This one is a dim date table. Take it easy. It's only the beginning we are doing right now. Whatever we are going to study right now is about data modeling. Okay, so it's a very conceptual subject, conceptual topic. So until we do some kind of a hands-on practice, our concepts are not getting cleared. Okay, so you need not take much of a headache. Okay. Pankaj. So what we have in yellow color over here is our fact table, and what we have in the blue color table is our dimension table. So whatever data we have inside our fact table is getting described by actually the data preparation area. Those space and get it into our single place where we perform this ETL operation. Okay, we perform this abstract operation where we extract our data from our original OLTP databases, transform that data so that we have relevant data inside of fact and dimension tables. Okay, so that is what that is done inside a server. So that is actually called a data staging area. It is not necessary that we may have a different server for it. We can have it in a very different database as well. So if I am right now working in a AdventureWorks database, okay, what I can do is I can take our data from AdventureWorks database, okay, and into a different particular database where I can do all the modifications that is required to make our fact and dimension table. Okay, we can do it either on the same system or on a different system. But if it is my production machine, I will not have been allowed to work day in and day out on my production server. In a real-time scenario I'm talking about. So on my production server, I will not have been given so much of permission to work on a day in and day out. So what I will have to do is, I will have to extract this particular database, copy this database from this production machine onto a machine which is not under active use, wherein I will perform this ETL operation. ETL is getting my data from this production machine onto a different machine, that is extract. Okay. Transformation is where we transform our data. Now look, whatever data we have inside our this particular table, it will be a very, very descriptive one. But while we are going for a data warehouse, I told you the data warehouse data has 4 properties. It will have consolidated and consistent data. It will be subject oriented. It will have historical data, and it will be non-volatile. So data warehouse, So data warehouse will have only data which is relevant to the topic for which we are going to make our reports or for which we are going to have our data warehouse. Okay, so we'll have to transform those particular tables from that particular data from that particular OLTP databases. So that is what our concern would be. So that is actually done at a place where we call it as data staging area. Next is presentation services. Presentation services is something wherein we are going to use our reporting service for this purpose, or we can also use our Excel, the MS Excel, to explore our presentation layer. So how are we going to present this data to the end user? That is taken care of by presentation services. And then what we talked about was data marts. So I told you data mart is actually a department specific data where we can have it. So what are performance or roles and responsibility a person has in the case of a data warehouse? Okay, so I'm just mentioning over here the roles and responsibility. In a data warehouse, the first is data abstraction, which we are talking about right now. One of the first particular objectives which we need to perform in this ETL tool, ETL operation. Next is data cleaning. So can you just imagine what is data cleaning?
Remove the duplicacy of data or something?
Not exactly, but you would have noticed that there are certain particular columns in a database which are empty. Okay, null columns are not allowed, null values are not allowed inside a particular table. So we'll have to substitute that. Okay, and also there is a possibility that the data inside a database may be inconsistent. Like I can describe, like I can describe the color of a dress as red, deep red, or rose red. But if my company says that I have to have a single name for all these three colors, okay, so what I will have to do is I'll have to be consistent in my database. I'll have to name all these three as the same color. I'll have to come sit down with the management. What would they want to name these particular data as? Either red, or deep red, or rose red. You see that all these three are same color, so I need to have a same name for it. So I will rather go for red. If the company says that I need to have a value of red in it, so I will replace all these columns with a single value, which would be red. Okay, did you get me? Or should I give you another example for it?
Oh, please, if you don't mind.
Okay, fine. So, okay, there's another example wherein you can say, like in India, what we have is some people describe their highest qualification as graduation. Some may call it as BSc, which is Bachelor in Science. Some may call it as BCom. Okay, and there may be in this particular table wherein we have this. Suppose we have a column by the name of highest qualification. Okay, and we have these particular columns in it. BSc, BCom, BA, okay, post graduate, and then I have more number of columns which are saying MA, MSc, okay, BTech, BE. Some may say it as high school. Suppose they are these particular columns. Okay, but if I want to be consistent with my data, okay, I have to go for data cleaning. Either I will have to mention or delete these particular columns, which is MAs and postgraduate mean the same thing, isn't it? Master of Arts is actually done after graduation itself, or Master in Science is done after graduation itself. So MA, MSc and postgraduate, all three mean you have something related to postgraduate. Similarly, BTech, BE, BA, BCom, BSc and graduation, all these are meaning the same thing, which is graduation. Okay, either we remove graduation and post-graduation from this particular table, or we remove BA, BCom, BSc, BTech, BE and keep the substitute as graduation, and instead of MA and MSc, I keep the substitute as postgraduate. Okay, so there has to be consistency which has been met in all the columns. Okay, because this is how our data is going to get filtered. So what I'll have, imagine, just imagine what kind of data is going to be saved in our fact table. Suppose this is my fact table for a particular student. I'm just designing a demo fact table and a dimension table for qualification. Okay. Now inside my demo fact table, I will have my student ID. Suppose my student ID is 100. Okay. And now this particular student has caste qualification, which I am going to denote as 4. So what will be the data inside my dim qualification? My data inside my dim qualification will have 2 columns, wherein the first column will have a key and the second column will actually describe what does this key mean. My first column will again have a key and this will describe what does this mean. Okay. So while I'm going to have more and more data inside my table over here, suppose my third column for student fact table describes the fee which is paying in the for the course. Okay, the monthly fees which is being charged for the course. Okay, so what we have is first column is the student fee. Then we have a column which is actually being linked to dim qualification table over here. Dim qualification is another table where we have 2 columns. The first column is the key and the second column is actually what is describing the key as. So once we look at our original database also, the same thing happens over here. This is a very important and table where we have this dim date. If you look at the dim date table, we have a date key over here. Okay, so each date key is actually describing a date for me. For the calendar year 2005, okay, and my calendar quarter 1, my month number of year 1, that is January, and day 1. So what is the key for it? It is 1/1/2005. So this one is getting a substitute for 1st January 2005. I'm getting a substitute for that as gate key. Similarly, over here, while I make a dim qualification table, I will have a substitute for graduation as 1, post graduation as 2, high school qualification as 3. So whatever kind of options we are going to have for qualification, I'll have to put a substitute for it as key. And once we are entering the data inside of fact table, it has to be a substitute for this particular key over here. We have to substitute it with a key over here in the fact table. And then we need to link, while I'm designing my cube over here. Now look, inside my data source view, what is happening is edit relationship. There is a relationship between ship date key and date key over here. Can you see the relationship over here? Kavish? Kavish?
Yeah. Carry on.
Okay. So this is a fact table and this is the dimension table. So these 2 tables are getting linked to each other, where the source table inside my fact table is going to a primary key and this is going to be a, the fact table is going to the foreign key and my key inside the dimension table is going to be the primary key. So there is going to be a relationship between my dimension table or the fact table. That's what is our objective while we are going to design our data warehouse. Okay, so
Isn't it get wrong other way around?
Sorry?
Isn't it get other way around?
No. Always the dimension table will have the primary key and the fact table will have the foreign key. Now
So
look at this particular table. Over here, the sales summary fact table is going to have a key column which is sales territory key. Now just identify with this one, the example which I showed you. For each column of each row is getting identified by a dim qualification key, isn't it? In a dim qualification table, if I have a first column as 1 and my second column as graduation, this means each and every row is getting identified by a dim qualification key, isn't it? So now here the dim qualification key is going to be my primary key for this particular table. Whereas this is going to reference this student fact table's second column, which is 4, which is going to identify the qualification of this particular student. Okay, so this 4, the second column is going to be a foreign key for over here. This is getting identified by my doctorate, which is 4 for dim qualification. So dimension table will always have a primary key and it will point to the fact table which will have a foreign key in it. So this is a basic concept we need to understand in the very first instance. Okay, so it's a very important part of data modeling. How we are going to model our data. Okay. So this is actually the main objective is to find out fact table and dimension table and to come up with a star schema in the very beginning. Okay. Then once we have this star schema, I told you once we have this schema, the view which we are talking about is a schema, and from this view we actually come up with a cube. The same data warehouse which I had made earlier, I will process a cube with it. These are my dimensions regarding my table. Various dimensions, they are looking for too many, but as you go ahead it will get more and more simpler. Okay, for my multidimensional concepts, we are coming up with a cube. Once you have this star schema, we process it and we come up with a cube. So cube is something which we are concerned about. Now look at this particular table. Same way, categories, products, components. These are all the things which you are going to come up with. This is how our dimension members would be going ahead. These are the labels or levels which we will understand how to come up with the levels for it. We'll look for aggregations. Because this we have to go as we go forward. So we'll look more and more into details regarding it. Fine, we did not overburden with it. We just need to understand the basics first of all before we start with this particular topic, which is SIS data flow basics. So there are going to be tools which we are going to use for abstraction. There are going to be SSIS tools which we are going to use for transformation, and there are going to be tools which are going for loading. Post transformation and then loading, that's what our purpose is. Loading into our destination is something which we accomplish in the end. So what are kind of data sources we have? We have our AD author data source, for which we have this custom data provider. We have our Excel source, even we can get our data from the Excel sheets. We can get our data from a text file or a CSV file. We can get our data from an OLAP file. We can get our data from any kind of raw files, and we can also get our data from an XML document. These are going to be our data sources, and what are going to be our data destinations. After performing my ETL operations, my data can be fed into another kind of data data provider. We can get it into a data reader object, into an Excel sheet, okay, into a text file,